Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 11 students in functions and relations who are working on the summative questions. And it's question number 19 from the summative package. A retirement savings fund earns 6.6% per annum compounded monthly. Calculate the amounts at age 60 that would result from. So we have a $200 monthly deposit that starts at age 20 and a $400 monthly deposit starting at age 40. All right, so what type of financial math are we talking about? Well, obviously what we're doing is we are depositing money regularly in order to reach a certain future goal. So that would be this equation. So regular deposits to reach a future goal. So we're saving up towards a goal, so this is what I need. So in both cases, we know um, we know everything on the right. We know that, for example, that we're going to do $200 of deposits, that we have a 6.6 interest rate compounded monthly, and we can calculate that, for example, the age 20 person, that would sit there for 40 years. So let's go ahead and do the calculations. So first of all, the $200 from age 20. So age 20, that means that this is going to happen for 40 years. So for 40 years, so from age 20 until age 60, this person is going to deposit $200 every month, and we'll see what that looks like when they turn 60. So the future value is, so the regular deposit of $200 times bracket 1 plus, now the interest is 6.6%, but it's compounded monthly, so I have to divide by 12 to reflect that. And my exponent, so it's 40 years, and it's monthly, so 12 times a year. So, and then subtract 1. So there's the numerator. And in the denominator, it's 0.066 divided by 12. So that's that 6.6% per annum, but compounded monthly again. So let's see what we have. So again, inside the bracket is a bracket, so I deal with that first. 0.066 divided by 12, and then I'll add 1, and I get 1.0055. So 1.0055, and the exponent is 40 times 12, so that's 480, and then subtract 1 and divide by, and I'll do 0.066 divided by 12. Of course, I've already done it above, I just added 1. So this is where I'm at. So now let's keep going. So 200 times, so 1.055, 1.055 to the exponent 480 gives me, ooh, a huge number. Yeah, sorry, 1.0055. Boy, oh boy, that was almost an amazing investment. 13.9122. Subtract 1. I guess I could have done that. Oh well. Divide it by 0.0055. So what do we get? So I'm going to take 13.9122. I'm going to subtract 1 minus 1. I'm going to multiply by 200. And I'm going to divide by 0.0055 and discover that this person would have $469,534.73, rounding up ever so slightly because it's a penny, not even a penny. So this person, the 20-year-old, um, who deposits for 40 years, would have $469,534.73 in that account. Oh, would be nice. And let's do the same thing now for the $40, sorry, for the 40-year-old who deposits $400 a month, and this time it's only 20 years worth of deposits. So, you know, this might be a good time to pause the video and try to do it on your own without me. Ooh. So we have $400, and that's going to be deposited for 20 years because from age 40 to age 60 is only 20 years. So how much would be in the account? So the future value is $400 times 1 plus, and it's still that 0.066 number. It's still compounded monthly, and this time it's only 20 years, but it's compounded monthly, minus 1, and all of this will be divided by 0.066 divided by 12. So some of the numbers stay the same, some of them are different. So let's do this math. So the future value is $400 times. So I know this. This is still 1.0055. This time my exponent is 240. Let me put this nice bracket in before I lose track. And we're going to divide by 0.0055. So let's do the math. 1.0055 to the exponent, 240 equals, subtract 1, multiply by 400, divide by 0.0055, and I get $198,538 and about 68 cents. So this is the amount of the $400 every month for 20 years. Okay, so we have that number and we have this number, and they're quite different. So what do we have to do with them? So here's part B. What is the total of the deposits in each situation? So let me just recopy from the other page. Oops, sorry. 20-year-old. So we're going to pretend that there's a 20-year-old who makes $200 deposits for 40 years. And then over here, we have a 40-year-old who makes $400 deposits for 20 years. And I'm going to go back and figure out what the total amount of those investments were. Oh, I reversed my color palette. Oh well. So the 20-year-old has 469,534.73. So this person over 40 years, including interest, would have this much money in their account. And the other person after 20 years would have this much money in their account, 198,538.68. Okay, so that's the information that we calculated in part A. So in part B, it says, what is the total of the deposits in each situation? So in other words, this person, how much money did they actually contribute to their amassed fortune here? So they made $200 every month, so every month for 40 years. So 12 months in a year for 40 years. So this person, oops, just pretend that didn't happen. This person actually ended up depositing $96,000. So over that 40-year period, they deposited $96,000 into the account. And let's do the same calculation for the 40-year-old. They made deposits of $400 every month for 20 years. Now, hopefully you can tell this is actually going to be the same amount. It's also $96,000. So they both actually ended up contributing the same amount. And this is where, the power of understanding financial math, because if you look, $96,000 over this person amassed to pretty close to $500,000. $96,000 for this person, $200,000. Now, of course, that's not a little bit of money, but compared to this, whew. What does part C say? How much did each investment earn? So here we go. So this is just reinforcing this idea that the first person who had a total of $469,434.73 and only deposited $96,000 earned a total of $373,534.73 in interest. So it's kind of nice to make money just because you didn't touch your money. This person obviously earned a lot less interest. This person ended up making 98. Oops. Oh, I could have done that in my head. Oh well. $102,000 and a little bit more. So again, it's still nice to make $100,000 in interest, but compared to the other person, ooh. And that's why part D of this question exists, is to get you to reflect on um, the impact of time on the future value of an investment. These people both invested the same amount of money, but that extra 20-year difference made a huge difference. Um, the more time an investment can sit, I guess I can say can collect interest, the better. So, you're young. If you have a chunk of money right now, deposit it. Let it earn interest. Do what the rich do. Don't spend your money. Let your money work for you, or blah 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 capitalist thoughts, blah blah blah. Or, hey, if you want, I know some math teachers who could use some money. I'm sort of just kidding. All right, I hope that was helpful. See you in the next video.